These will be the notes for section 6.4, rectangles, rhombi, and squares. Our objectives are I will be able to recognize and apply the properties of rectangles, rhombi, and squares. So first off, let's start off by saying what a rectangle is. A rectangle is a quadrilateral. Remember, that's a four-sided shape with four right angles. So four congruent angles, four right angles. And another thing that's important about a rectangle is it's also a parallelogram. So whenever we talked about in our last lesson all about those properties of parallelograms, they also carry over for rectangles. Another thing that's special about a rectangle, so it says if a parallelogram is a rectangle, then the diagonals are congruent. So we're going to use that feature, the rectangle having congruent diagonals, to be able to solve these examples here. So what I would like you to do is to try the evens. We're going to do the odds together. So it says find the measure of each angle. Well, what's the measure of angle 1? If I look at this rectangle, I see that we have this triangle in red. This triangle is going to be isosceles because I know that the diagonals are congruent. That's what we just said above. And also the diagonals bisect each other because it's a parallelogram. So the base angles of an isosceles triangle are congruent. So the measure of angle 1 is going to be 32 degrees. The next problem asks us for the measure of angle 3. To solve this one, the easiest way is probably easiest to find angle 2 first. So the measure of angle 2 plus 32 plus 32 equals 180. So the measure of angle 2 is just going to be 180 minus 32 minus 32, which is 116. So we'll fill that piece of information in also. So we should see we have a linear pair between angles 2 and 3. If angle 2 is 116, well, what's angle 3 need to be? Well, those are supplementary. A linear pair adds up to 180. So we just have 180 minus 116, which is 64. Let's figure out what the measure of angle 5 is. We'll do this triangle in green. So we have another situation where we have an isosceles triangle, and we know that measure of angle 3 is 64 degrees. So we know these two are the same. The base angles are the same. So x plus 64 is equal to 180. We get 2x plus 64 is equal to 180. And we subtract 64. So we get 2x is equal to, let's use our calculators to make sure of this, 116. And lastly, we divide by 2. So we get 58 is equal to measure of angle 5. Just a quick note on how to solve the last one, the measure of angle 6. Remember, we have a right angle here. So the measure of angle 1 plus the measure of angle 6 is just going to equal 90 degrees. So that was a lot of talk on angles. The next set of examples has us finding side lengths. So we're told we have a rectangle, and we're told to find each of the following. So we have segment BC. Segment BC is right here, and we should know that since a rectangle is a special type of parallelogram, the opposite sides are congruent. So BC is equal to 12. What about DB? Well, DB is just right here, and we know that the diagonals are congruent. So DB has to be equal to the other diagonal, which is 20. And lastly, we have CO. We know that CO and AO are congruent because the diagonals bisect each other. That's a property of a parallelogram. So we should see that CO is 10 and AO is 10 because 10 plus 10 is 20. So again, I would like you to try the evens. Keep moving on. We're told to find the value of x. We have more rectangles we're dealing with. So the first problem says du is 26. So it's always a good idea to label your picture. So du is 26 and dp is 2x plus 7. We had a problem just like this above where we saw that the diagonal gets bisected, it gets cut in half. So we're going to have two smaller pieces, 2x plus 7. So we have 2x plus 7 plus 2x plus 7 equals that whole line, which is 26. That's the setup for this problem. So now we can solve it. 2x plus 2x is 4x. 7 plus 7 is 14 equals 26. We subtract 14. 4x is equal to 12. And lastly, we divide by 4. And we get x is equal to 3. Number 14, you should be able to do it on your own. But let's just start number 14 off. The measure of angle 2 is 52 degrees. And the measure of angle 3 is 16x minus 12. What do we know about this triangle? We talked about this property several times before. It's isosceles. So that should be enough information for you to try 14 on your own. Let's move on to page 2. We're still working on solving for x. So we're told the measure of angle 4 is 6x minus 16, and the measure of angle 5 is 2x plus 4. So what's the relationship between angles 4 and 5? Well, they're a linear pair. They form a straight line. That means they're supplementary. They add up to 180 degrees. So 2x plus 4 plus 6x minus 16 is equal to 180. When we combine like terms, 8x. So this is a minus 16 here. We have minus 16 plus 4, so that's going to be minus 12 is equal to 180. We add 12. 8x is equal to 192. And then we divide by 8. So we get 192 divided by 8, which is 24. Again, you should be able to try 16. And for 17, we have the measure of angle 3 is 70 minus 4x. And the measure of angle 6 is 18x minus 8. This one's a little bit trickier. You have to remember some things about parallel lines. It's a rectangle, we have parallel lines. So you should see that angle 6 is going to be equal to this angle right here. So this angle right here is 18x minus 8. And now that I have that, I know that these two angles form a right angle. So now I'm ready to solve it. 18x minus 8 plus 70 minus 4x equals 90. Remember that 4 angles in a rectangle all are 90 degrees. So we have 18x minus 4x, so it's 14x, plus 70 minus 8, 62, is equal to 90. We subtract 62. 14x is equal to 28. And lastly, we divide by 14. So we get x is equal to 2. The setup on this problem is a little bit trickier, but this is something that you should know how to do. Maybe we're in the process of just getting to be familiar with the rectangle and everything, but this is a problem we've been doing almost all year, starting with parallel lines. So we talked about rectangles. Remember, rectangles have 4 right angles and their diagonals are congruent. The next shape we're going to talk about is a rhombus. So for a rhombus, it's a quadrilateral. And like the rectangle before it, it's also a parallelogram. The thing that's special about a rhombus is it has 4 congruent sides. So if we have a rhombus here, there will be 4 congruent sides. A rhombus has a couple of special properties. The first one is if a parallelogram is a rhombus, then its diagonals are perpendicular. So for any parallelogram, the diagonals bisect each other. For a rectangle, they're congruent. For a rhombus, they're not congruent. They still do bisect each other because it's a parallelogram. But the special property here is we have 4 right angles. Another theorem is if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So what this is saying is a rhombus will create these congruent pairs of angles. It bisects those opposite angles. So if I take a look at this, I can label some things to kind of help us out here. We know that we have 4 right angles here because it's a rhombus. So it says ABCD is a rhombus. And we know that the opposite angles are going to be bisected. So we're told if AE is 8, we're missing the most. If AE is 8, what is AC? Well, because a rhombus is a parallelogram, we know that the diagonals bisect each other, so AC has to be 16. Now we come into those other properties. If the measure of angle 1 is 37, what's the measure of angle 4? Well, 1 and 4 both have 2 tick marks next to them, so they have to be congruent. So the measure of angle 4 has to be 37. Then it says, what's the measure of angle 6? Well, angle 6 has 1 tick mark next to it. 1 angle mark next to it, I should say. So if I would look here, all 3 of those angles have to add up to 180. So for this example, angle 5 is equal to 37. So we have the measure of angle 5 plus the measure of angle 6 plus 90 equals 180. Do you see that blue shape I drew as a triangle? Those 3 angles have to add up to 180. So whenever I substitute 37 plus, we'll call that x, plus 90 equals 180. Remember, I'm looking for the measure of angle 6. So all I have to do is just subtract those numbers. So it's 180 minus 37 minus 90. We get 53. So I'd like you to try problems 3 and 4. And we're going to take a look at number 5. So it says if AD, here's AD here, is 3x plus 7, and AB, which is right here, is 5x minus 3, what's x? Well, these are sides to the rhombus. We know that all the sides of the rhombus are equal. So that means that 5x minus 3 equals 3x plus 7. And then we just do a little bit of algebra. We have to get our x's on one side. So 2x minus 3 is equal to 7. Get our numbers on the other side. 2x is 10. And then we just divide by 2, and we get x is equal to 5. Again, we have some more properties of a rhombus. We're going to do problems 7 and 9 together. I want you to try 6 and 8. So problem 7 says, if the measure of angle 2 is 3x minus 4, and the measure of ADC, so we have ADC, so that's this whole angle here, is 2x plus 32, what is x equal? We should remember from our other picture that all 4 of these little angles will be congruent. So that means that we're going to have 3x minus 4 is equal to angle 3. So if I would redraw this, I would say the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 7 plus the measure of angle 6. I already have this right here. The measure of angle 7 plus the measure of angle 6 is this angle right here. So this is 2x plus 32. The other 2 angles are both 3x minus 4. So I have 3x minus 4 plus 3x minus 4. That's how we set this up. There's a lot of looking at pictures and analyzing them to see what we have going on. Whenever I combine like terms, 6x minus 8 is equal to 2x plus 32. Subtract 2x. 4x minus 8 is equal to 32. Add 8. 4x is equal to 40. And we divide by 4. And we get x is equal to 10. And let's take a look at this last one here, number 9. It says if AE is equal to 16, BE is equal to 12, what is AB? Remember, the diagonals form a right triangle, 90 degrees. So since we have this, when we see a right triangle, there's 2 things we can do. We can either do the Pythagorean theorem or trigonometry or SOHCAHTOA. We should be seeing that we have a squared plus b squared is equal to c squared. So we have 16 squared plus 12 squared is equal to c squared. We put that in our calculator. 16 squared plus 12 squared is 400. Take the square root of it. So second square, 20. So AB is going to be equal to 20. So a little bit of a review on the rhombus. We said that the diagonals were perpendicular. All 4 sides were congruent. and the opposite angles bisected each other. Lastly, we have the square. A square is a quadrilateral with 4 congruent sides and 4 right angles. So a square is both a rectangle and a rhombus. So a square is a rectangle and a rhombus. It has all of the properties. So we're told ABCD is a square. The measure of angle 3 is 4x minus 7. We know that it has to be equal to the measure of angle 4 also, because that's a property of a rhombus. So 4x minus 7 plus 4x minus 7 equals 90. Combining like terms, 8x minus 14 equals 90. We add 14. 8x is equal to 104. And we divide by 8. Sorry, I didn't divide. We get 13. Let's move on to number 12. The measure of angle BEC is 7x minus 1. So remember, we have BEC. So this angle here is 7x minus 1. A rectangle, or sorry, square is a rhombus, so we know that's equal to 90 because the diagonals are perpendicular. So we get x is equal to 13 again. The last one we're going to do together is number 14. It says if AD is equal to 3x minus 1, and the perimeter of the square is 140. So that's whenever we add up all the sides. What's x equal to? Well, all the sides are congruent. It's a rhombus. 4 times 3x minus 1 is equal to 140. We just distribute this. 12x minus 1 is equal to 140. We add 1. 12x. Sorry, this should be 4. Forgot to distribute the 4. 12x is equal to 144. Divide by 12. We get x is equal to 12. So you should try 11 and 13, and we'll continue to practice on this in class.